Hi, if you are watching this, you've probably applied to our coding bootcamp and you've had the first meeting already, either with me or with any of my colleagues. And you're here to study for the technical assessment, but don't worry, it's not as scary as it sounds. To set yourself up for success here, you're gonna need two screens. One screen where you're following along the tutorial, and the other screen you'll use that for actually coding along with me as we progress throughout the tutorial. And if you for some reason don't have access to two screens, it's not the end of the world. You can just split the two screens. It's not going to be as efficient, but it will do. And the key thing here is that you actually code along with me throughout the entire session. You have to type exactly what I'm typing, because if you just watch the tutorial, you're gonna feel like you kind of understand what I'm getting at. You'll feel like you understand the concepts, but you're not gonna be able to put them into practice at the technical interview. So to succeed, you're gonna have to engage with the content, try some things out on your own and stay curious. Ultimately, this technical assessment is about testing your motivation and your ability to pick up a couple of simple coding concepts on your own and then being able to put them into to practice. Okay, so when you're finished with the coding tutorial, there are a couple of exercises that I want you to do as well. You'll find them in the email or here in the YouTube description. And my recommendation is that you spend 3 to 4 hours studying and preparing for this technical interview. You definitely don't need more than that to complete or to pass the technical assessment. Okay, let's get into it. Righty, so first thing that we are going to do is to download the Anaconda distribution. So you're gonna go to anaconda.com/download, link in the description here. And then when you go to this page, you could sign up, but it's not required, so you could just click skip registration here. And then you'll end up here. And then depending on which processor you have, you can select that here. So make sure you do it correctly here, and then just download it, click through all of the steps. Then when you're done with that, we're gonna go to GitHub. And then you're gonna go to this link. Link is in the description. And then what you want to do is you want to go to here, and then you can just download this folder. Okay, now we're going to open up Anaconda distribution. And then what we can do is that we can open up the terminal. You can do spotlight search to find it, terminal, and then just open it up. Here you can type upython notebook. And you have to type it exactly like this. And then you press enter, and that should open up upython for you. So if you downloaded it, the GitHub repo, it's probably here in your downloads folder, so then you can click your way here. Okay, so now we are in this folder. You should have managed to find it, and then we're gonna get started with the code along. So you can open up this notebook here, and this is where you're gonna write all the code to follow along in the tutorial. So let's get started with it. So as you might know, Python is the most popular programming language in the world right now, and it was created to be easily understood by anyone who speaks English. And one of my favorite things about Python is that it comes with so many built-in functions. So if you would do like a computer science degree, the first thing you would do in your first course would be to print out the string hello world. And since Python already has a built-in function for this, it's incredibly easy to do so. All you need to do is to say print hello world within a string. And then to execute the code here, you do shift enter. So it's super easy. In many other programming languages, you would have to write a lot more code to make the computer print out this statement to the console. And the great thing about Python is that for a lot of the cases, you would just need to know that there is a built-in function for the problem that you're trying to solve. and then you would just need to know how to use it. Another example of that would be the input function. So if I say input, I could add a string here. What's your objective? Like that. It's also nice to put a little space here. And then we execute this by pressing Shift Enter. So now we're prompting the user for some input. So it pops up a little box here. I am learning Python. You can put that here and press Enter. And then we're getting this as an output. So we have 86 built-in functions in Python, and not having to write all of these things from scratch saves us as Python developers a lot of time. So we have also the sum function, for example, which allows us to sum up the numbers in a list. Looks like that. And then before we move on to variables, so I just want to show you how a UPython notebook works. So a UPython notebook is made up of cells. So this here is a cell, it's a code cell. This is actually a cell also, it's a markdown cell. You can see here that it says markdown. If I go to the code one, it's going to change the code. And then I can go here and change this to a markdown, but then if I run it, it's not executing the code. I have to change it to code to be able to run the code. Then I can create a new cell. If I'm inside of the cell is green. If I press escape, it turns blue. When it's blue, I can press A to create a new cell above the cell. Or if I go back here, so now this one is blue, or I press B, then I can create a cell below. If I want to delete the cell, I can mark the cell. It has to be blue. If it's green, it doesn't work. So turn it blue. You can either make it blue by pressing here or by pressing escape when it's green. And then you press D 2 times to delete the cell. Can delete this one as well. All right, so moving on to variables. So a variable in Python, I can create a variable now saying my goal, and then I'll set it to be equal to a string. And then I execute it. So now I've created a variable, and the variable is a name that stores some data in the memory of our computers. You can think of it as naming a Microsoft Word document. Once you've named it like Resume 2025, you don't need to remember everything that you put in the CV, but as soon as you need it, you can reference that document by its name, Resume 2025. It's the same thing in programming. If I'm working with a large chunk of data, I want to give it a name so that every time I need to work with that chunk of data, I can get all that data by referencing the name. Oh yeah, it's also super important that we put effort into coming up with descriptive variable names, because it's going to make your code a lot easier to understand. So here I've created a variable called my goal, and now if I just type out my goal and run that code, I will access the data from that variable name. And there are a couple of important rules for naming variables that you should be aware of. Never give your variable a name that turns green. So don't name it for, don't name it return, don't name it sum. If it turns green, it's either a keyword or a built-in function. So if I were to name a variable sum and then set it equal to some number, I would overwrite the sum function. So then I wouldn't be able to use the sum function anymore because I would have overwritten it. If you would make this mistake, which I hope you won't, you can fix it. It's not the end of the world. What you have to do in that case is that you'll have to go up to kernel here and restart and clear output. or just restart it, because that will delete all variables and allow you to start fresh. Another rule, always use lowercase letters and never start a variable name with a number. You can have numbers in your variable name, but never in the beginning. And finally, you can't have any white spaces. If you want to have white spaces, you'll have to replace the white space with an underscore instead. And it has to be an underscore because that's important. It's called snake case. And that's what we use in Python. So that's a little bit about variables. And now I want to talk about data types. And we have 4 data types. We have 4 data types. And you can think of data types as the smallest building blocks of data that we're working with in a programming language. And as you can see here, when I'm using the hashtag, use the hashtag to create a comment. So you can use this hashtag and then put any type of text, any comment or anything, and it's not going to be interpreted as code. It's a great practice to get into the habit of commenting your code. Back to data types. We have the strings. The string data type is what we have up here in my goal. Strings are a string is one of the 4 data types in Python. We use strings for text information. So this is a string. We use that for text information. And then we have integers. Integers look like this. So an integer is just a number. And the reason we want to be able to work with numbers is because we want to be able to perform mathematical operations. Therefore, math stuff. And then we actually have another numbers data type, which is called float. And they are used for math stuff with decimal points. So a floating point number looks like this. Then finally we have booleans. And that's the last data type, and it only has 2 values, true and false. It's like on and off. They're great for decision making because they allow us to set up conditions that we can act upon. So if something is true, we can go ahead and make a specific action. We can go ahead and perform an action. It looks like this. So you just write true, or you could write false. And it has to be with a capital letter there. So strings is the only data type that uses quotation marks. The other ones, you don't need a quotation mark. So why do we have different data types? Well, it's because they all have different purposes. So a string, that's used for text information or to edit text. So that's something we could do with a string. We could edit it and update it. So strings like this, we could say then add a new string here. So now I'm concatenating new information to this string. And that's something I can only do with a string. For example, I can't do math with a string. If I would try to say 22 plus 23 using strings, I would just concatenate the 2 strings together. So if I want to be able to do math with strings, I'm going to have to say maybe, okay, integers plus floats. And speaking of math, in Python, that's super easy and straightforward. It's basically just like using your calculator on your phone or your computer. So addition, you already saw that. That looks like this. Subtraction looks like this. You can see here I'm actually adding a white space in between here. And that's not something I have to do, but it's appreciated by others if you do that. It makes your code look a lot neater. And then we have multiplication. Looks like that. And then finally we have division. Maybe I'll do it like this, 4 divided by 2. So you can see whenever I'm doing division, it's returning a floating point number, and it's always going to do that, even if it's something that could be converted into an integer. And then finally, if I say 5 to the power of 2, I have to use 2 multiplication signs like that. So 5 to the power of 2. All right, so one final thing here about variables is that it's a good idea to start using variable names for mathematical operations. So when you start solving problems with Python, it's good to get into the habit of creating variables. If we have a problem, we need to calculate the area of a circle. We want to start figuring out what parts we need to do that. So to calculate a circle, you would need the number pi, which is this, and then we would need a radius, which we can set to 6 for now, and then we can calculate the formula. So the area uses these two, so we're just saying pi multiplied by the radius to the power of 2, and then we can print area is 113. Okay, so moving on to if statements. If statements is what lets our code make decisions. It checks whether something is true or false, and then runs different code depending on the result. We use this logic in our everyday life as well. For example, if I'm bored, I'm gonna go stare into my fridge for a while. So it starts with a statement that can be either true or false. So in this case, it was bored. Is that true or is it false? If it's true, I go and do something. Let's try that in Python here. So if I set up a variable, call it is raining, and I set it to true. Then I can create an if statement, say if is raining. Then I'm just gonna print bring an umbrella with you to work today. First thing that happens is that we're registering this variable, and then we go to the if statement. The if statement will check if this is true or false, and since it's true, the code underneath the if statement will be executed. So if I change this to false, then we're not gonna execute the code underneath the if statement. So it's only when something is true that an action is being performed. Let's try a different example. Let's try adding the else statement also. So I'm going to start off here with my age, and I'm going to say here entry age 18. I'm going to start with an if statement here, and I'm going to say my age is greater or equal to entry age. So if it's true that this number is greater or equal to this number, well then I'm gonna print you may enter the bar. And then we're gonna have an else statement here. And in the else statement, I don't need to put a condition, because the else statement, you can think of it as a kind of a backup plan, a second path your code can take when the previous conditions has evaluated to false. And in this case, if you're not old enough to go into a bar, you're by definition too young. So it's mutually exclusive here. So I could set up a condition and write it out something like this, but reversed, but I don't need to do that. So it's better to use an else statement. So then I just say print, you are too young to enter the bar. So if I run it, it says you may enter the bar because this evaluates to true. So when this evaluates to true, we go into the if statement and execute the code there. So in this case, it's just a print statement, and then we skip this part. If we lower my age to 17, then this evaluates to false. We skip this part here, and we go straight into the else statement. Now we're just going to try one final example here and add on a couple of stuff. So I'm going to start by creating two variables. So I'm going to say if rental and not gentle, print it's a rental, don't be gentle. Okay, let's dive into this here. So first thing we're unpacking here is the elif statement. So we're not limited to just having if and if else. We can create an if statement and then follow with as many elif statement as we want. So first here in the if statement, I'm checking if it's a rental, if that's true, and if it's not true that you're gentle. So basically, if this, in this case right now, with these variables here, we have not gentle, which means not false, and not false is true. So this actually reads if true and true, so true and true is true. That means that you have rental skis and you're not gentle with them. And then we have an elif statement saying if it's rental and you're gentle, then we're like, okay, why would you be so gentle with those rental skis? And then if it's not a rental and you're gentle, you're getting the print statement that, well, you're taking care of your skis and that's good for you. In the else statement should actually be like that. Then we're saying, yikes, you need to buy new skis if you don't take care of them. So that would be a case where you're mistreating your own skis. All right, so that's if statements. We're gonna come back to it a little bit later when we're talking about loops. But before that, we're gonna talk about lists. And we're gonna try to understand the properties of the most used data structure. We actually have 4 data structures in total, but for this technical interview prep, you're only gonna need to understand lists. So remember when I said that data types are like the smallest building blocks of data, yeah? Data structure is like a big container where we can store tons of data types. You can think of it as a drawer, and then the data types would be all the stuff that you keep in that drawer. So it's a great way of keeping track of all your stuff. and that's why we want data structures. And as you can see, I have a list here. You should have on your notebook as well. So the list is created with these brackets. So it has an opening bracket here, and then it has a closing bracket here. And then we have elements here. So we have some strings, and these are all information about what a list is. So lists, they're ordered, meaning that we keep track of all the elements or all the data types in the list by their index position. And also lists are mutable, which means that we can change, add, or remove items from the list after having created it. So it's very versatile. You can work with it in a lot of different ways, and you can also have any data type inside of the list. And I'm just here, I put a boolean, an integer, and a floating point number to show you that. And also I put in a list in the list to show you that you can even put a list into the list. So if I run that, you can see I can access facts about the list here. I mentioned that lists are ordered sequences and that every element has an index position. So I could use the built-in function called len, which is short for length, and see how many elements or items I have in my list. And here you can see I have 7 items. So from the perspective of this list, I have string 1 string, 2 strings, 3 strings, the 4th element, the 5th, the 6th, and then this entire list is the 7th element. If I want to access an individual element from the list, I can get that element by the index position. So to get a number by index position, I have to type out the name of the list, and then I need to do these brackets. And then to get the first index position, I have to put 0. 0 is the first index position. In Python, the index starts with a 0, and it's for the same reason that the first minute of a football game is minute 0, or when you're born, for the entire first year of your life, you're 0 years old. So it makes sense to do it like that. If I want to get the last element, I can't put 7 because it's going to say list index out of range. So it has to be 7 minus 1 since we're starting on 0. So here I'm getting that entire list that we had in the list. Another way of getting the last element would be to say -1. So then I'm going from the end of the list to the start. So saying -1 is it's called negative indexing, means that we're starting from right and going to left instead. And sometimes people ask me why it's not -0 here, and that's because -0 doesn't exist. 0 is just 0, -1 exists. So that's good to know. And then we can say -2, of course. We could say, to get the first element here, we would say -7. Okay, so indexing gives us one element. But what if I want to have several elements from a list? Well, then I have to turn to something that is called slicing. And to slice, we have to specify a start and a stop index. So it looks like this. I type out the name of the list, I do brackets again, and if I want to go from the first element maybe up to the 4th element, so now the start index is 1 and the stop is 4. So you can see here that I'm getting the first index position, so this one, and it goes to the 2nd, the 3rd, up to the 4th, but it doesn't include 23, which is index position 4. So it's inclusive on start index. By that I mean, since I'm specifying 1 here in the start, I'm actually getting the string with index position 1. but for the end, I'm not getting index position 4. I'm getting up to index position 4, but it's not inclusive. So stop index is exclusive. And that's important to remember. If you want to go from the start index, you could specify 0, but it's a lot cleaner to not do so because you don't need to. And well, how do you go up all the way from a specific point, from any starting point up until the end? So if I want to start from 3 and go all the way up to the end, I can't put 6, right, which is the end index, because it's going to go up to 6 but not include index position number 6. So what I do to go up all the way to the end is that I just don't put anything here in the end. So I leave that part empty, and then I go all the way to the end. And the final thing that you need to know about lists is the most common list method. It's called append. Totally delivers on its name. That's what it does. It appends, it adds something to the end of a list. So I can just say facts about lists dot append. Append is the most common method for lists. See you at the end of the list. And then we run it. You can see it doesn't give me an output here, and I don't need to save it to a variable. It's going to make a change in that list in place. So it's just updating the variable without us having to overwrite it. So you can see it pops up here. Now we have a new element added to the list. Okay, moving on to for loops, and now we're really getting to the interesting parts here. So a loop is a programming construct or a concept that allows us to repeat a set of instructions multiple times. It's like telling your computer to say, hey, do this thing over and over again until a specific criteria is met. So loops is the reason why computers are good at carrying out repetitive tasks very, very fast. So yeah, put in a definition here of what a loop is. So a loop is a set of instructions that are being repeated over and over again until a condition is met. So let's have a look at that in a for loop. So let's look at the syntax. First we say for I in, and I can say range 100. So by saying this, for I in range 100, I'm setting a condition, and this condition is do something 100 times. So I've set the condition, but now I need a set of instruction. What is it that should be done 100 times? Well, let's print the definition. Oops, let's have to run this code first. The definition of a loop. So now what I've done is that I've printed the loop definition 100 times. So the set of instructions are print the definition of a loop over and over again. So it does that iteratively 100 times. And when it's done it 100 times, the condition has been met. So that's a loop. And one type of loop is that we use the range method. Then we can sort of generate or set a specific number of iterations that we want to perform. The other type of loop is that we're looping over a list or a data structure. We can also loop over strings, but the most common thing that you'll see is that you loop over lists. So if I want to loop over a list, I can say for day in, I'm going to run this here also, daily sales, and for now I'm just going to print day so you see what the loop is doing. So when I'm saying for day in daily sales, I'm iterating over this list, and I will do as many iterations as there are elements in the list I'm iterating over. And you might also wonder why I put day here and I put I here. Well, it's to show you that you can put any name here. And the most common thing I would say is that you'll see that people put I here. Some people put X, but I is the most common, especially when you're looking at Python code. It's basically just like a temporary variable that exists within this loop. And the reason why I put day here is because when you're starting to learn about loops, it's a good idea to try to give this variable a name that represents each iteration. If we look at daily sales here, we have a number which is the sales for our fictive company a specific day. So every value here represents one day. And the loop is going through every element one by one. So on the first iteration, day is equal to this. On the second iteration, day changes and it's equal to this. So for each iteration, day has a new value. So now, let's change it up a little bit and let's incorporate if statements together with loops. So I want to print out the days where sales exceeded 3,000. Okay, so if I want to do that, first thing I want to do is that I want to go through every day one by one. So I need to set up this loop structure. For each day, I want to have an if statement. I want to check, okay, is the day greater or equal, or it actually says exceed 3,000, so just greater than 3,000. If it has exceeded this, then I want to print that day. So if we compare these two loops now, here we're just going through all of the elements one by one. The step that we're adding here is that we're saying if the day is greater than 3,000, we're still going through this number in the iteration. So we're still going through everything, but we're only printing the day if this case is true. Okay, so now I've only showed you how to print things in the loop, and that's a great way to start off. But once we start solving more complex problems, you're not just printing things, because printing is just something that we do to see what's going on in our program. Normally, we want to store the data somewhere. And I want to show you a very common approach to solving problems in Python using loops. Common problem that you'll face a lot of the time is that you have a list, or you have something that you can convert into a list, and you need to go through every element in the list and check for one or more conditions, and if those conditions are true, you want to take all those numbers, whatever it is, and append them to a new placeholder list. So let's try this approach for the same problem here. We want to see how many days we sold for more than 3,000 bucks, or whatever the currency is here. We start with a placeholder list. So I'm going to call it over 3K. And it's just going to be an empty list like this. Then we go into the loop. So we say for day in daily sales. And we can just say if day is greater than or equal to 3,000. Well, instead of printing now, I'm going to say over 3K dot append. So instead of printing it now, I'm going to append it to this empty list. So I'm going to append the day. And if I run it now, you can see I'm not getting an output because I'm not printing anything, but we can have a look at over 3K like this. So now we can do length to see how many days we actually sold for more than 3K. It was 8 days. We could also maybe see for how much we sold these 8 days. Okay, let's move on to functions. So if you remember from the beginning of this code along session, I said that Python is great because it comes with a great set of built-in functions. And that's really nice because we can just call a function by its name. So if we want to print something, I just call a function by its name, right? Print. And then I give it some input, which is this string. Give some input. And then I just execute the code and it prints something for me. So this is a built-in function, but we can also create our own functions in Python. To do this, we have to use the def keyword and then we specify a name. So let's create a function for calculating the area of a circle, because that's something we already know how to do. So circle area. So I use the def keyword here to tell Python that I'm going to create a user-defined function. Then I come up with a name for the function, and then afterwards I put the parenthesis and then a colon. Now in the parenthesis I can add one or more arguments. So an argument is an input that you need to feed the function to make it work. So it's not mandatory for all functions to have input, but in this case we're going to need to feed the function some input. We're going to need to feed it the radius, for example. You could also add pi here, but since pi is always the same, is a fixed number, it would be a little unnecessary to add it in here, because really radius is the only thing we need to provide, and we can just have pi inside of the function here. So let's put it here instead. And then if we have pi and the radius given to us, we can calculate the area of the circle, which is basically pi multiplied by radius to the power of 2. And then in the end of the user-defined function, we're gonna use the return keyword. And the return keyword determines what the function shall return back to us. So what the function does is that when we call it, you feed it some input and then it returns some sort of output. Let's see what happens now when I run this code. Nothing happens. And that's good, because nothing should happen here. And now I want to explain a key distinction that I see my bootcamp students get wrong all the time, or at least they have a hard time to grasp it. And that is that creating a function and calling a function, two separate things. So when we create a function, like we did here, you're just saving some sort of logic into the computer to be used at a later stage, right? And then once we have created it, we can call the function. So then we're using the logic that has been stored by calling the function. So calling a function, I do that by its name. So I named it circle area, and then I just say circle area. So you can see here the syntax for calling this function is the same as the syntax for calling the print function. Just say the name. It's like calling a function is like calling a friend. You use their name. That's it. And that's how we call a function.